All right, welcome back, everyone. Ready for another deep dive?
Always ready.
Awesome. So today we're going to be looking at something kind of fascinating, something you probably interact with all the time without even realizing it. Motion time series data.
Ooh, that's a good one.
Yeah. I mean, think about it. Your
hmm
smartwatch, your fitness tracker, even just your phone, they're all constantly collecting data on how you move.
It's amazing how much information those little devices pack in, right?
It really is. And, there's so much we can potentially learn from all that data. Like, seriously, a treasure trove of insights just waiting to be unlocked.
Totally. Everything from how we walk and run to, even more complex things like recognizing different activities and patterns in our movement. It's incredible.
It really is. But the problem is, well, analyzing all that data can be a bit of a nightmare.
Oh, yeah, definitely. Talk about information overload.
Exactly. Because you've got all these different devices, different sensors, different ways of capturing movement. It's like trying to solve a jigsaw puzzle, where every piece is from a different puzzle.
It's definitely a challenge. I mean, even if you just think about something as simple as walking, everyone does it a little differently.
Right. Like, stride length, speed, all that stuff.
Exactly. So you have all these individual variations on top of the differences in how the devices themselves are recording the data. Things like sampling rates, sensitivities of the sensors. It's a lot to untangle.
Yeah, and that's what makes it so tricky to analyze, right? That huge variation in the data.
Right, exactly. It's what we call heterogeneity in the data. It's kind of a mouthful, but basically it just means the data is coming from all these different sources and looks really different, even if it's capturing the same activity.
So how on earth do we make sense of all this chaotic data?
Well, that's where things get really interesting. There's this new method that's been making waves called UniMTS.
UniMTS. Okay, I'm intrigued. Lay it on me. What is this UniMTS all about?
So, in a nutshell, UniMTS is trying to create a single system that can understand and learn from motion data, regardless of where it comes from or what activity it's capturing.
So it's like a universal translator for motion data.
Exactly. It's designed to cut through all that heterogeneity and extract meaningful insights from the data.
That sounds incredibly ambitious. How does it even work? What's the secret sauce?
Well, UniMTS uses a really clever combination of two powerful techniques: contrastive learning and masked reconstruction.
Okay, those are some pretty big words. Break it down for me. What is contrastive learning, and how does it help with this whole motion data puzzle?
Sure. So imagine you're teaching a kid to tell the difference between a cat and a dog. You wouldn't just show them one picture of each, right?
Right, you'd show them tons of pictures, like a whole album of cats and dogs.
Exactly. You want to show them enough examples so they can start to pick up on the subtle differences, the things that make a cat and a dog a dog. Contrastive learning works in a similar way, but with motion data.
So instead of pictures of cats and dogs, it's looking at, like, data points from a smartwatch.
Yep. It analyzes vast amounts of motion data, but instead of just looking at individual data points in isolation, it's comparing and contrasting different activities.
Okay, I think I'm starting to get it. So by comparing and contrasting all this data, it's learning to tell the difference between different movements, like, say, walking versus running.
Exactly. And it goes even deeper than that. It can even learn to distinguish between subtle variations within the same activity.
Oh, wow. That's pretty cool. So it's like teaching the computer to be a motion expert. You can look at a bunch of data and be like, yep, that's definitely someone walking, and that's definitely someone sprinting.
Precisely. It's all about pattern recognition. And here's where it gets even more interesting.
Oh, there's more. Okay, I'm all ears.
All right, so we've got contrastive learning, which helps UniMTS differentiate between activities. But now we bring in the other secret weapon: masked reconstruction. Think of it like this. You've got a jigsaw puzzle, but some of the pieces are missing.
Okay, that's frustrating. I hate when that happens.
Yeah. Right. But what do? You look at the pieces you have, you look at the picture on the box, and you try to figure out what the missing pieces should look like. That's basically what master reconstruction is doing.
So it's like UniMTS is trying to solve a motion data puzzle with some of the pieces missing.
Exactly. It's trained to predict those missing data points based on the information from surrounding data points. And this forces it to really understand the underlying patterns and structure of the movement.
Okay, I can see how that would be super helpful. But filling in those gaps accurately must be ridiculously challenging, especially with all the variations we were talking about earlier.
Oh, it absolutely is. Motion data is inherently noisy and complex. But that's what makes UniMTS so powerful. It's able to account for all those nuances and still make pretty darn accurate predictions.
Okay, so we've covered how it works. Now, let's talk about the fun part, the so what part. how can we actually use UniMTS in the real world? Give me some examples.
Oh, the possibilities are endless. This is where it gets really exciting. Think about personalized fitness tracking. Imagine your smartwatch, powered by UniMTS, could not only track your steps, but also analyze your running form. It could tell you if you're overpronating or heel striking and even give you personalized tips on how to improve your technique.
Wait, seriously? That would be a game changer. It would be like having a personal running coach right on your wrist.
Exactly, and
Hmm.
it goes beyond running. It could do the same thing for swimming, cycling, any activity you can track with a wearable sensor.
That's amazing. And you know what else would be incredible? If it could use that data to recommend exercises or workout routines that are tailored to your individual needs,
Yeah.
right, based on your movement patterns and your fitness goals.
Absolutely. That's totally within the realm of possibility with UniMTS. It's all about using data to create truly personalized fitness experiences.
That's the future right there.
Yeah.
Okay, so we've got fitness. What else can this thing do?
Well, let's talk about healthcare.
Oh yeah, there's got to be huge potential there, right?
Huge. Think about physical therapy, for example. UniMTS could be used to track a patient's progress in real time, providing feedback to both the patient and the therapist.
So it's like an extra set of eyes helping to ensure the patient is doing the exercises correctly and making progress.
Exactly. And it could even help to identify potential problems early on, preventing further injury.
That's incredible. And we can't forget about fall detection, especially for elderly folks. We talked about that a bit earlier.
Yeah.
But how does UniMTS actually detect falls?
So falls usually involve these sudden, rapid changes in motion and orientation, going from standing to horizontal pretty quickly.
Right, makes sense.
And UNMTS can pick up on these anomalies by analyzing the acceleration and rotation data from wearable sensors. It can distinguish between, say, a normal stumble and a dangerous fall, which could be life-saving in some situations.
Right, it could trigger an alert to a caregiver or even emergency services.
Wow. Exactly. So you see, it's not just about recognizing activities. It's about understanding the context of those activities and identifying potentially dangerous situations. That's where the real power of UniMTS lies.
This is all just blowing my mind. I mean, it's not just analyzing data. It's like it's understanding human movement on a whole other level.
It is, and we've only scratched the surface here. Think about things like creating more responsive and immersive virtual reality experiences.
Oh, yeah. Like, imagine a VR game where your movements are translated into the game world with incredible accuracy.
Exactly. Or even using UniMTS to control prosthetic limbs with greater precision and intuitiveness. The possibilities are truly mind-boggling.
It sounds like UniMTS is more than just a cool new technology. It's a potential revolution in the way we interact with technology and the world around us.
I couldn't agree more. It's definitely something to keep an eye on. As the technology continues to develop, who knows what other creative and innovative uses we'll find for it.
Well, I, for one, am incredibly excited to see where it all goes. Thanks so much for taking us on this deep dive into the world of motion time series data. It's been fascinating.
My pleasure. Always happy to nerd out about this stuff.
And all our listeners out there, thanks for joining us. Keep those brains and bodies moving, and we'll catch you on the next deep dive.
See you then.
Bye, everyone.
Bye.